Hi and hello people, welcome back once again to our channel Vagai Academy of Mathematics. And here this session we again have a question from CAT 2022 under the concept of progressions. Let us see the question. Consider the arithmetic progression 3, 7, 11 and so on. So we have the progression, we have the numbers 3, 7, 11 and so on. So by looking the progression itself, it is very clear that it is an AP arithmetic progression, right? And what about the first term? It is going to be 3. So let's take a note of it. A, the first term of the arithmetic progression is going to be 3. And what about the common difference? D is going to be equal to, see here, it is going to be 4, correct? So 3 plus 4 is 7, 7 plus 4 is 11 and so on. So common difference D is going to be 4 and so on. And let an denote the sum of the first n terms of this arithmetic progression. Now we need to know the sum of the first n terms of an AP also. Here we have the formula Sn. Sn is actually what is sum of the first n terms. It's given by n by 2 into 2a plus n minus 1 into d. So this is going to be the sum of the first n terms. And yes, then what we need to find here is we need to find the value of 1 by 25 of summation n runs from 1 to 25 an. So we need to find the simplified answer for this expression. We have the options also. Now let us easily see the approach how we can solve this problem. Okay, yes. Now first of all we should focus in finding what is the first n terms of this arithmetic progression, and this is denoted by an in this particular problem. So an is going to be 1. Let us use this Sn's formula. Okay, so Sn is going to be n by 2 into, so n by 2 into 2a. So 2a plus n minus 1 into d, right? So what about 2a? 2a means it's going to be 2 3s are 6 because a is 3, right? So 2 3s are 6 plus n minus 1 into d, which means it is going to be like 4 into n minus 1 because d is going to be 4, right? So n minus 1 into d. Okay, yes. Now this will be equal to, further simplified it as 2 n by 2 into, now what about this expression? This can be written as 6 plus, multiply this 4 inside, you will get 4n minus 4, and this can be simplified as n by 2 into 4n plus 2, is it or not? So this way we can rewrite it. Okay, now further continue this. Now when I do it, I will be getting n by 2 into, I can take 2 as a common factor outside. If I do it, I will be getting 2n plus 1. So this can be finally simplified as 2 and 2, I can cut it. I will be getting n into 2n, which will be 2n square, plus n into 1 will be n, simply n. Okay, so our an is going to be this expression only. Okay, let's have a note of it. This is what is an. But what we need to find here, find the value of 1 by 25 multiplied with summation of n runs from 1 to 25 of this an. Okay, this is what we need to find. Now let's do something here. 1 by 25 into, let's substitute this expression for an in our question. So we will be getting summation n runs from 1 to 25. So this will become of 2n square plus n, because this is going to be the value of an, right? That's why. Okay, now I can first of all separate the sum, because we have two terms having in the summation. So I will just separate the summations itself as, I'll separate it as two summations. Okay, so 1 by 25 of, now I will open a bracket. So this is going to be 2n square first. So summation n runs from 1 to 25 of 2n square. Since this 2 is a constant, I will take it outside. So I will be having 2 times of summation n runs from 1 to 25 of n square, summation n square, plus the other summation will be what? This will be simply summation n runs from 1 to 25 of n. Okay, so yes. Now if you closely look at this, this is going to be the sum of squares of first n terms, and this is going to be the sum of first n terms. We need to know the formulas here. Okay, so I've written the formulas here. Sum of the first n terms will be n into n plus 1 by 2. You must be knowing it. And summation of the sum of first n square terms will be n into n plus 1 into 2n plus 1 whole divided by 6. Let's use these formulas here so that we can easily simplify and get the answer. So 1 by 25 of, here 2 into, now what about this one? This will be the sum of first n square terms. Okay, so which means n is going to be taking the value 25, because first 25 terms we are going to take. So take the formula and put n as 25 there. So we'll be getting 25 into n into 25 into n plus 1. What is n plus 1? That will be 26 into, what about 2n plus 1? 2n plus 1 is going to be 2 into 25 plus 1, which will be 51 whole divided by 6. Then plus, Now here the second summation will be n terms, right? So n into n plus 1 by 2. Again take n as 25. So 25 into 26 by 2. This is what we will be having. Now all I can do is I can try to simplify this. So I will be getting 1 by 25 into. So maybe I can cut these expressions, okay? So yeah, I'll cut it like this, okay? Listen very carefully. How I'm going to do is I will cut this 26 and 6 in 2 tables. This will become 13 times because 2 into 13 is 26, and here 2 3s are, and once again this 3 and 51 I can cut for 17 times. 3 17s are 51, right? Let me do the same here also. Here I will have 2 and 26 for exactly 13 times. So now I have with me is 2 into 25 into 13 into 17 plus 25 into 13. Okay, now I will take a 25 into 13 common outside. So what I will be having inside is, just listen very carefully. When I pick 25 and 13 outside, I will be having 2 into 17, which will be 34 here, plus here, what about here? This position I will be having 25 into 13 that came outside. So I'll be simply having a 1 inside. Okay, yes, that's it. Now finally I will be cutting this 25 and 25 because this 1 by 25 is common to all the terms inside. So I will be having 1 by 25 of 25. I can cut this. So I'll be having 13 into, this is 34 plus 1, 35. So this will become 35 into 13 will become 350 plus 105, which will be 554, 455. So 455 is going to be the answer, and that is ready available at option C. So option C, 455 is going to be the answer for this progressions question. I hope the steps are clear to you. So have a view of this. And again, let's catch up in the next session with some other interesting question. See you soon there. Thank you so much.